Hey guys, welcome to week 3 CAD, and today we'll be going over holes. So as you've been taught before, there are many ways to do the same operation, and the hole tool is one way that you can implement holes or other cylindrical extrusions in your CAD very simply and very powerfully. This is done through accessing a library of fasteners that already exist in the software, so that all you need to do is point and click a location for your hole and tell it some dimensions about the fastener you plan on putting there, and it will automatically draw in the dimensions for that specific fastener and the specific type you've chosen. So, just a quick look at the dialog available to you when you choose the hole. You'll need to choose some input geometry. This is simply the location for the hole. You choose some type, so whether it's a simple hole, which is literally just a cylindrical extrusion downwards, or maybe it's a clearance hole, where I've given it a type of fastener, and the software knows certain dimensions to autofill for that hole. And the same can be said for the tapped hole. Um, both of these should be size 4, yet they're different dimensions. This is 0.112, and this is 0.129. This has to do with the machining process of being able to slide a fastener through a hole or being able to tap into it. And of course, you can even edit things like the seat of the screw. Being able to add a countersink in one click is very powerful and requires a lot less work from you rather than trying to implement this cone feature yourself. Now, of course, down here we can change the behavior of it. It's really good about figuring out what direction you want the hole to go, but maybe if it got it wrong, you can flip the direction. And it doesn't have to go all the way through. It can stop at a certain surface. And then the diagram at the bottom lets you change specific dimensions of your fastener or of the hole to match the fastener. Here we still have the countersink dimensions, which means that if we configure this correctly, the screw that we input to this hole that we manufacture will sit flush with the surface. So those are just some powerful things that you can configure with the hole tool. As with many things in Inventor, there's a lot of options for you to choose to get the same operation. But commonly, what you'll do for choosing a location with your hole is drafting a sketch with the hole locations specified with points, and then applying your hole feature to that. Now, to get a lot of practice with the hole tool, we're going to create a real BattleBots part involved with one of the 60-pound weapon assemblies. Here you can see their weapon has several screw holes, and it even has some that you can't see just right yet. But we'll go through how to make this part, and by the end of it, you'll know how to use the hole tool like a pro. So to start, we'll want to create this sketch. Starting at the XY plane, let's give ourselves a circle, 13 inches. Zoom out a bit here. Right. Let's get these reference lines here. We'll make them roughly 1 inch. 1.5 inches. And then we'll choose the arc tool, center point arc. We want the center point for this arc to be at the tip of this line. Starting from the tangent of the circle, draw it up around out like this. We'll do the same thing for this guy here, out to this tangent point. Draw it out to the horizon. We'll then dimension from here to here. Oh, that's good. And it should be symmetrical. You'll want to remember to close off this geometry so that we can properly extrude it. Alright, that should be good. Zoom out a bit here. We'll extrude this. Here we go. Alright, so selecting the profile of these three guys. We'll extrude it 0.75 inches. And there. Now have a basic profile for the part. So now, we'll go ahead and start a new sketch from what we've already created here. And it looks like we want to cut out rectangular bits from this part. So let's go ahead and project the geometry of this part into this sketch. And we'll start a rectangle from this corner here. And we'll draw it out 2 inches across and 0.005 tall. There we go. We'll do the same thing on the other side. And there we go. Finish this sketch up. And extrude. Extrusions don't have to just add material, they can also take away. So we'll select these two profiles, extrude into the part, and make sure your boolean is cutting. And there you go. So now we've got a part that looks a little bit like this. Let's go ahead and change the view up here. Here we go. So now we're going to add some holes to attach the teeth of this weapon, right? The teeth of this weapon will be made out of steel. We want to attach them right here. So we'll start a new sketch from this face. And according to the initial specifications, we want a hole 1/2 inch from the wall here at the center line. We'll just draw this out and manually input 0.5. And 1 inch from that hole. Alright. Let's go ahead and turn these into construction lines here. Oh, there we go. And then using our point tool, we'll just go ahead and specify where we want the holes. Alright, finish that up. And by simply selecting the sketch and choosing hole, you now have holes started at those points. For the settings on these holes, we'll want 0.75 deep, which we have. Size 0.25. So let's go ahead and edit that here. There we go. Make sure these updated correctly. So this guy looks like he got changed. Set him back. Here we go. And actually, the hole goes deeper than what we want tapped. So we'll input here. There we go. Alright. Double checking, all the settings seem alright. We'll go ahead and pull the trigger on this. There we go. We have our holes that we wanted. Let's change the view here. Holes we wanted right here. Up to spec. So we'll try a different method now. Let's say our specifications changed. And instead we want 4 holes, 1 inch from each other. And they're not going to be 1/2 inch from the outer edge. They'll be 1 inch from the outer edge. We can look at how we can do this a little bit better. So we'll start off and we'll add our measurement here from the center line, 1 inch inwards. We'll make this construction just to be sure that, hey, we're not using this line for anything other than measurements. We'll add a point here. And making use of that really useful pattern tool, we'll go ahead and make a rectangular pattern, choosing this as the geometry we want to copy. And then for the direction, choose that construction line. And you can see now it follows the construction line and copies a point over here. We want 4 of these points, so we'll just go ahead and edit that value there. They're already defaulted to 1 inch apart. That's cool. And we'll hit OK on that and finish up this sketch. So as you can see here, it added 4 points an inch apart from each other, which is up to our specifications without having to manually add each point. Now this is really useful because you could do an array of points, not just a line, but lines on lines. And you can dynamically update the distances between them by just editing that pattern. So we'll just go ahead and grab that sketch again and run the hole tool on it. We'll be using these settings for the hole. We want size 10. So that's going to be up here. Size 10. We want it just all the way through. And yep. Now this is a weird hole we've made. It went all the way through the part, but it could be whatever you want it to be. Now we'll make a D slot. Now D slot is very useful for, really anything that spins, because it gives you control over what angle you have it at. So to demonstrate that, we'll go ahead and create another sketch. We made a sketch on that surface, but we're not going to have to project geometry because we just want this center point. Let's go ahead and grab point tool. And that's all there is to it. We'll finish the sketch here. Highlight the sketch, run the hole tool. And in our specifications, it's set to 50 millimeters of a simple hole. This is strange, but you could have to deal with millimeters, maybe if your stock only comes in metric, or any number of different factors. Maybe the part you order that configures with this other part really just only comes in metric. All you have to do is just type mm and it handles all that for you. Alright, and this goes all the way through. Yeah, we'll just set it to go all the way through. Alright. So now we have a hole meant for a shaft. And as you can see with this hole, if you put this on a shaft, it would freely spin no matter what the shaft did, which is not great for BattleBots. We want to have control over a shaft, importantly to add force to it. So what we'll do is we'll add a D shape to it. So another sketch here. We'll go ahead and use the rectangle tool. Maybe try and get on the line and just draw out a rough shape of what you want. Alright, I'm just going to drag this bottom line under. There we go. I want the corner of this rectangle to be coincident with the circle. Oh, there we go. And based on the specifications given, it has to be 1.181 inches across. So we'll just go ahead and dimension that in manually. And there we go. It says we need another dimension. That's going to be the height of the rectangle, but for now that doesn't matter. Now we'll grab that sketch, run the extrusion tool on it. It wants us to select the profile. There we go. We don't want it in this direction, we want it downwards. And the Boolean is still set to cut. We're not trying to cut a material, we're trying to add material. And there we go. So now what we've created is a D slot. If your shaft also had the same D shape, you could see how spinning the shaft would force the part to move, as the part wouldn't be spinning freely on it. Would there be a geometry there forcing, force to be transmitted. And now we'll add one more feature to this. We're going to throw a point on here. Let's say right here. We want it to, did I get that origin there? Okay. We want it to be 2.625 inches above it, and it's already coincident with the y-axis, so the x dimensioning is not needed. We'll finish up this sketch, and using this hole, or using this point, we'll run the hole tool on it, and this is going to be a tapped hole, size 0.375. Oh, this is too large. Here we go. We want it to go all the way through the part, and we'll hit OK. So this hole is going to fasten the part to some axle, right? We want some other part to mate with this, and we'll put a couple of screws into it to put the two parts together. One hole is not going to be enough though. That's not enough screws. So instead of manually adding each screw in a circular fashion, we'll go ahead and use that circular pattern again, choosing the hole geometry. Now you can see in this part we're using features to be patterned instead of geometries like points or lines to be patterned. Rotational axis, well, we know we made this on the XY plane. We'll mouse over these, and yep, the Z axis is what goes through. And there we go. We want 8 of these. We'll just type in 8 here. And the pattern tool automatically creates 8 holes that are circularly fashioned around the origin, with all the same specifications. And in fact, if you just edit the one hole, it will cascade through all the other patterned holes, which is very useful if you want to change maybe your screw sizes. Later on in the design, you decide, oh, the screws we chose, they're not going to be strong enough for the force we're putting on this. Let's make them larger. You just change this one hole and your design cascades. Yep, so we use the circular pattern on this hole. You could have used the circular pattern tool within the sketch on the points instead of the holes themselves. Same end result. Like we always say, there's a lot of different ways you could do the same thing in CAD. And yeah, there you go. This is a senior member's BattleBot part. And yeah, you can see the hole tool is very powerful.